In this section, we'll be focusing on direct variation equations. First, we'll be deciding if a direct variation equation exists given an x and y relationship. Then we'll be graphing a direct variation equation, and then we'll be writing a direct variation equation given data. So the first thing we need to do is identify what a direct variation equation is. And a direct variation equation is a linear equation where the ratio of y over x remains constant. A direct variation equation is written in the form y equals ax. A is called the constant of variation. And so this equation is extremely similar to y equals mx plus b. And the reason that they're very similar is because in both cases y is isolated. But the difference is that in the direct variation equation, as opposed to the slope-intercept equation, b, or the y-intercept, is always 0. So to be direct variation, you always have to have a b of 0. And if you look here, since there's nothing being added or subtracted, then the only thing that you could add or subtract without changing it would be 0. Since b is always 0, then what that's going to mean when you graph it is that the graph will always pass through the origin, or 0, 0. So just to recap, direct variation is when you divide y by x if it remains constant. We're going to see that in a few minutes. But it's written in the form y equals ax, which is very similar to y equals mx plus b, except here b could be anything. It could be 1, 2, 3, 4. It's just that if b is 0, then it's direct variation. Once something's direct variation, you can just call a, it has a special name called the constant of variation. It is in the same spot as the slope, like a is multiplying x, slope is multiplying x. So the constant of variation and the slope are essentially the same. It's just that this is a more special version, so it gets a more special name. So down here on these examples, we're going to see if the equation can be written as a direct variation equation. If yes, we're going to identify the constant of variation, or a. If no, we would say why not. So the first thing we want to do is isolate y. So on this first example, to isolate y, I would subtract 2x from both sides, which gives me negative 3y equals negative 2x. Then I would divide both sides by negative 3, which would give me y equals positive 2/3 x, because remember, two negatives make a positive. So if I'm looking at this equation to see if it's direct variation, I basically want to see right now is b 0? And the answer is yes, b is 0. So yes, it's direct variation, which means I have a constant of variation, or an a. In this case, a is 2/3. So yes, a is 2/3. So I'm going to look at this example just for a second, and then I'll have you do some practice on your own. So in this example, if I want to isolate y, I would add x to both sides. So I'd get y equals 4 plus x. So if I'm looking at this equation trying to decide if it's direct variation, I want to see if b is 0. If the y-intercept is 0, then it's direct variation, but b is 4. So no, it is not direct variation because b is 4. So you're going to pause the video, and you're going to try these 3 examples. Press play when you're ready to check your answers. So in this example, to isolate y, I'd add x to both sides, and then since b is 1, then it's not direct variation. On this example, I'd subtract 2x from both sides. 0 minus 2x is just negative 2x. Since b is 0, there's nothing being added or subtracted, then yes, it is direct variation, which means I have a constant of variation, that's a. A is negative 2. And on this example, you subtract 4x from both sides, then divide by negative 5. So y equals 4/5 x. b is 0. There's nothing being added or subtracted, so yes, it's direct variation. The constant of variation, which is a, is 4/5. So on this slide, we're going to do some investigation to just kind of prove why direct variation is direct variation. So the first question just says, for the graphs drawn below, which equation represents direct variation and how do you know? So if we just look at these two graphs, we're going to go based on what we know so far. And what we've been talking about is that if the y-intercept is 0, then it's direct variation. So based on that, I would say that graph B is direct variation because it has a y-intercept of 0. Graph A has a y-intercept of 1, so it's not going to be direct variation. So graph B, and it's because it has a y-intercept of 0. So the next thing that we're going to do is we're going to fill in each ordered pair. So I'm just going to start by doing one of them. So for example, this ordered pair right here is over 0, up 1. So you're going to pause the video and fill in each of these ordered pairs for both the red and the blue graphs. Press play when you're ready to check your ordered pairs. So just check to make sure that you have 1, 4, 0, 1, negative 1, negative 2, negative 2, negative 5, 4, 2, 2, 1, negative 2, negative 1, negative 4, negative 2. So the next thing that we're going to do is in each ordered pair, we're going to take the y-coordinate of the ordered pair and divide it by the x-coordinate. So just for example, if I did that here, it would be 4, that's my y, divided by 1, which would be 4. And I want to do that for every single ordered pair, red and blue. The only one I'm actually going to skip is this one, because if you try to divide 1 by 0, it's going to give you an error. So do every other ordered pair. So this one, and all 4 of these. So you're taking the y-coordinate and dividing it by the x-coordinate. Pause the video, press play when you're ready to check your answer. Okay, so we had already done the first one. 4 divided by 1 is 4. I'm going to skip this one. Here, negative 2 divided by negative 1 is positive 2, and negative 5 divided by negative 2 is positive 5 over 2. I could make that mixed, but you don't need to. If I look at these ordered pairs, so if I do y divided by x, it was 2 divided by 4, which is 1/2, 1 divided by 2, which is 1/2, negative 1 divided by negative 2, which is 1/2, and negative 2 divided by negative 4, which is 1/2. So if we look at question 3, it says, what do you notice about the ratios in graph A? These are my ratios right here, compared to the ratios in graph B. And so hopefully what you're noticing is that in graph B, they are constant, meaning they're the same every time. A was different every time. So that's really what makes something direct variation, is if when you divide an ordered pair y by x, and then another ordered pair y by x, and then another ordered pair y by x, if you keep getting the same ratio, then it's direct variation. If you keep getting a different ratio, it's not direct variation. Now we can take it a step further and go back to graph A, because there is something that's going to be constant about graph A. And it says instead of dividing by y by x, pick any 2 consecutive ordered pairs and find delta y over delta x. So for example, these 2 ordered pairs right here, consecutive means next to each other. So change in y, 1, 2, 3, change in x is 1. And if I do that again, change in y, 1, 2, 3, change in x is 1. Change in y, 1, 2, 3, change in x is 1. So this time, it's not y divided by x that's constant, but delta y divided by delta x, or change in y over delta x, or change in x is constant. So anytime change in y over change in x is constant, what that's telling you is that you have an equation that is linear. And if you look at the blue equation, obviously it's linear, it forms a line. When you take the delta part out of it and you just divide y by x, and that's constant, it is linear, still forming a line, but it's a special kind of line, and it's direct variation. So now we're going to get into the graphing, but we actually already know how to graph these. We're going to graph them the exact same way that we graphed y equals mx plus b, which when you graph y equals mx plus b, you start at the y-intercept, and you go where the rise and the run tell you to go. The only difference is that these all happen to have the same y-intercept, and they all happen to be 0. So when I graph y equals 2/3 x, the first point that I graph is going to be the y-intercept of 0. Then I'm going to go where my slope tells me to go, which is to rise 2, 1, 2, run 3, 1, 2, 3, and I'm going to put a point there. And then I would do that repeatedly, 1, 2, 1, 2, 3, which isn't anything new. And then I could do some in the backwards direction as well. So I could go down 2, left 3, and then I would connect those with a line. So there's nothing really changing about how I'm graphing these lines. I would graph it the exact same way as if it had said y equals 2/3 x plus 1. It's just that it's plus 0. So the first point that I graph is the origin. And just to do one more, if I come to this one, again, my y-intercept is 0. My slope is -3, which is really -3/1. So I'm going to rise down 3, run 1. And I'm going to keep doing that over and over in both directions. And then I would draw my line and connect. So there's 2 more examples. I want you to pause the video and graph both of those. Press play when you're ready to check your answers. So on this first graph, we start at the origin, rise 2, run 1, or down 2, back 1. On this one, we start at the origin, slope of -1/2, so we're going to rise down 1, run 2, down 1, run 2, up and back, connect with a line. So the next thing we're going to do is we're actually going to write a direct variation equation. So we're going to start with the formula for direct variation, which is y equals ax. So basically what we're going to try to find is all direct variation equations are going to be the same. They're all going to be y equals something x. And we're really looking for that missing something. So every answer will look like this. You just want to fill the box with the number. And if you look at the formula, the missing box is your a, your constant of variation. So the next thing that you're going to do for step 2 is you're going to plug in x and y. So I have y equals ax, that was my first step. And if I look at the graph, here's the x and y that I'm given. And so as an ordered pair, that's -1, 2. Remember, ordered pairs go x, y. So that means that y will get replaced with 2. A is what I'm trying to find. X would get replaced with -1. And so then I'm going to solve for A. So in this case, A is being bothered by -1. It's multiplying, so I would divide. So I get A equals -2. But then that's not my answer, because the directions were to write the equation. So I want to go back and plug A into y equals ax. So I can now fill this missing box with -2. So my final answer would be y equals -2x. The reason you don't change x and y to numbers is because, remember, a line is made up of infinite points, and points are made up of x's and y's. So this just happens to be one of the points on the line, but the x and y represent all the infinite possibilities. So your final answer here is y equals -2x. So the last thing I'm going to do is answer the second question, which says to find y when x equals 60. So I would take my direct variation equation. I'm looking for y. And it's asking for when x is 60, and so then y would equal -120. So using the steps on the page before, write the direct variation equation of each of these examples. Pause the video, press play when you're ready to check your answers. So you're going to start with your formula, y equals ax. We're looking for the missing a. I'm going to use the ordered pair from over here, which has an x of 4 and a y of 6, and I'm going to plug that in. So replace x with 4 and y with 6. To isolate a, divide both sides by 4, but 6/4 would reduce to 3/2. Just be careful, you're not done yet. The final answer is when you plug a into the equation, so y equals 3 over 2x. That's your direct variation equation. Then part B asks you to find y when x equals 24. So I just replaced x with 24. Because it's fractions, I cross-canceled, so y would equal 36. In this example, here's my x, here's my y, so y gets replaced with 3, x gets replaced with 2. To isolate a, I would divide both sides by 2. A equals 3 over 2. So my direct variation equation is y equals 3 over 2x. And then replace x with 14. That would cancel, become a 7, would equal 21. So down here, we're going to start to get into word problems. So it says the number S tablespoons of sea salt needed in a fish water tank varies directly with the number W of water gallons. So one sentence that we're going to use a lot to help us is that Y varies with X. That's always true, and that's going to help us figure out what X and Y are. And in this case, use a highlighter, you can see that S varies with W. So I'm going to write that right here. S varies with W. So when normally this would mean y equals ax, what I can essentially do is everywhere I see a y, I can change it to s. Everywhere I see an x, I can change it to w. So it's going to be the equation s equals aw. And I know that it's not w equals as because I matched it up with this. And so now I'm going to plug in the information that they give me, which says that it's 100 tablespoons of sea salt, so that's S, to 20 gallons of water. And so to isolate A, I would divide both sides by 20, and I would get that A equals 5. But again, I'm not looking for A. I am, but that's not the question. The question is to write the direct variation equation, so it would be S equals 5W. So now I'm going to use that to find the number of salt, which is S, if I had a 30-gallon tank, so they're telling me W. So I would need 150 tablespoons of salt. So in this example, you're going to start by creating the sentence, something varies with something, right below y varies with x. You're going to start with y varies with x and then create this sentence, but for this problem. You're going to set up and solve your direct variation equation and then also solve part B. Pause the video, press play when you're ready to check your answers. So since I know that y varies with x and p varies with e, my equation is going to be p equals ae. The weight on Pluto is 6 when the weight on Earth is 100. To isolate for a, I would divide both sides by 100, which reduces to 3/50. And then I plug that back in, p equals 3/50 e. Then I replace e, which is the weight on Earth. That's what they're giving me. They're asking for the weight on Pluto. So 750 on Earth would translate to 45 pounds on Pluto. So in this example, it says that the table shows that C, which is the cost of downloading songs, which is S, vary directly. It says C varies with S. So that means C equals AS. So the first thing that it wants is to explain why C varies with S. So what we recognized earlier is that the definition of direct variation says that if you divide y by x and it's constant every time, then it's direct variation. Well, in this case, remember that the direct variation equation is y equals ax. So C is really our y, and S is really our x. So what that means is if every time we divide C by S, if it's constant, then it's going to be direct variation. So my first C is 297, and I'm going to divide that by 3. And if you do that, you're going to get 0.99 or 99 cents. My second cost is $4.95, If you divide by that by 5, you're going to get 0.99. And then your third cost is $6.93. And if you divide that by 7, you're also going to get 0.99. So because every ratio is constant, then it is in fact direct variation. And every time I divided, they were equal, and they equaled 0.99. That's actually my constant of variation, or my A. So I can write my equation that the cost is 0.99 S. And then this would also make sense because if you bought 0 songs, your cost would be 0, which means your graph would pass through the origin, which we also learned about direct variation. And there's nothing in the problem talking about paying, let's say, like a membership fee or anything that you have to pay up front that would not make your cost 0 when your songs are 0. So you're going to pause the video. You're going to try this example down here. So first you're going to explain why C varies with D. And then once you've explained that, you can write your direct variation equation. Press play when you're ready to check your answers. Okay, so if I start with the sentence, y varies with x, and then C varies with D, I know that C is really y and D is really x. So instead of y equals ax, I can set up C equals ad. To explain why C varies with D, normally to explain direct variation, you divide y by x. But in this case, y I said was C, so I'm going to divide C by D. If every time I divide C by D, it's constant, then it's direct variation. So my first C is 2577, divided by 3 is 859. Then I did 5154 divided by 6, which is 859. 7731 divided by 9 is 859. So every time I divided C by D, it was constant, which means it's direct variation. And the thing that it divided out to get is actually your constant of variation. So I can just take this number and replace it with A in the equation, so C equals 859D.